This is year 10 notes. We're on unit number 7 and we're looking at reflections as part of our transformations unit. So let's take a wee look. So it says to reflect a shape in a given mirror line, we count from each vertex to the mirror line perpendicularly. Count this distance on the other side and get the position of the new vertex. Do this for each vertex, and by vertex of course then we mean corner. Reflect triangle ABC in the line y equals -1. So the line y equals -1 is one where all the y coordinates are -1. So if you're not sure, let's pick a few. Let's go for 3 -1. 3 -1 is here. Let's go for -3 -1. I've just picked these at random, but I know the y coordinates -1. -3 -1. So it's going to be this line here. It always feels wrong because the y-axis goes this way, but that's the way these lines work out. So that's the line. Y equals -1. So we're going to reflect this one and call it A dash, B dash, C dash. Here's my line here, nice and straightforward. That's 2 squares, so we go 2 squares this way. This is 3 squares, so we go 3 squares this way. And this then is 4 squares, so we're going to go 4 squares this way. We have to label this one A dash, B dash, C dash, make sure and get them the right way around. So here is our equivalent one of A, so that's going to be A dash, then B dash, and C dash. Part B, in the line x equals 3, so it's one where all the x coordinates are 3, so there's 3 -1, we have that. What about 3, 4, 3, 4, 3, 2, so you can see it's then going to be this line here. It messes up our other ones, so that's okay. That's the line x equals 3, so we'll label this one while we're at it. That was y equals -1, and label it then LMN. So something weird's going on here. It's actually going through our shape. So if this is 1 square away here, then this is going to be moved into over here. This is 1 square away, so it's going to go this way. This is 2 squares away, so it's going to go this way. So it's just going to look like a wee shape going through the actual mirror line. So we have that, and we have that, and then to label these, so A is equivalent then to L, so my A was here, so this will be my L. B is the same as M, so that's B, so that's going to be M, and then my other one is going to be N. Reflect the triangle ABC in the line y equals x and label it A dash, B dash, C dash. So line y equals x, we've done a couple of things in this. You can do it that all the x coordinates are the same as the y coordinates, or if you want you could do y equals mx plus c and realize m is 1, so it's a gradient of 1 and a y-intercept then of 0. Cross one up 1, cross one up 1, or just plot ones where the coordinates are the same as each other, 1, 1, 2, 2, 3, 3. So this is a diagonal line. This can be a wee bit harder to reflect because we need to do our perpendicular working lines. So that's a line y equals x. That's handy where I've written it, so it looks like that anyway. Perpendicular working lines, so we want to count diagonal squares across. This is quite hard to do. So because it says, remember, it's always says to do it perpendicular. You see, I'll go back to this previous page so you can see. Count from each vertex to the mirror line perpendicularly. So going from here to here, that is 1 diagonal square. So I'm going to go 1 diagonal square out this side. Don't know if you can see that, that's quite hard to see. And that's going to be C dash. This is 1 diagonal square as well, actually. Again, it's quite hard to see because your measure, remember, has to be perpendicular, so that's a wee right angle there going that way. So my B dash is going to be here. And then A is actually just half a square away. So my A dash is going to be half a square then out the other side. You have a messy work in there, but it hopefully gives the idea. Once you have it drawn, you can kind of nearly tell if it looks right. Anywhere as well where it crosses the mirror line should be the equivalent point then on the other side. So I can see that it looks a bit like a butterfly, I suppose, and that's my shapes then drawn like that. I think our final example then for this, let's just check maybe with more. Nope, we're good. Draw the line which reflects ABC onto DEF and find the equation of this line. Not really too much to that one. So there is my line. Hopefully most of you can see that. If you want, you could always count squares. We don't really need to. I think it's quite obvious here. This is 2 squares, so it's going to be half away. This is 4 squares, so it's going to be half away. This is 8 squares, so it's going to be halfway. What's the name of this line? You can give it 2 names. We can call it a y-axis, but we normally call this the line x equals 0, which is our y-axis, and that's reflection then in x equals 0.